Hello everyone. Today we're going to be looking at the division of polynomials. How can we apply the remainder theorem when we're solving problems? And also looking at synthetic division when we are talking about dividing polynomial expressions. So when we're working with the polynomial division, we want to go back into the old long division of numbers, where you take a look at the number and you see how many times it'll go into the dividend, and so like 12 goes in 27 two times, which is 24, and then you take this value and you subtract it. 27 minus 24 is going to be 3, and then you bring down the next value in your dividend, and then you continue with this process until you end up with a value that is less than your original divisor, and then that's going to be your remainder. And so notice that this number is the quotient plus the remainder divided by the original divisor. So when we look at this in terms of polynomials, we're going to do the same thing, except we kind of temporarily blind ourselves to this idea of the plus 2. You look only at the first term, so then it's x goes into 2x squared how many times, or better, it's what do you multiply x by to give you 2x squared, and that is 2x. Then you distribute the 2x across the divisor. 2x times x is just going to be 2x squared, and then 2x times 2 is 4x. But then you're going to subtract this value. You're going to subtract this entire value. The 2x squared cancel out and becomes 0. But then 7x minus 4x is 3x. And then you bring down the remainder of that dividend. And so then, again, you are ignoring this plus 2 for just a moment. You have x. X times what value is 3x? Well, that's going to be 3. Distribute the 3 across x plus 2, and you get 3x plus 6, and you get a remainder of 1. So since the degree of the remainder is now less than the degree of the divisor, meaning that this value has no single x values in it, we'll call that the final remainder. And so then you have the quotient, which was 2x plus 3, plus the remainder, which is 1, divided by the original divisor, which is 2. So assume that we want to divide this function by y minus 3. First step is to write the polynomial in terms of descending degrees. So you start with your highest power first, and then you move to your next lowest power, and your next lowest power, and your next lowest power. If you are missing a value, so we have y cubed, y squared, the next term would be y to the first, but that's missing. So we're going to add in a 0y. This spacing is going to help us solve this problem. And then we continue dividing the same way as in the prior problem. So again, I'm going to go much faster this time. We temporarily ignore the minus 3. We look at y and say y times what value is going to give you 2y squared. Well, it's going to be 2 times y squared equals y cubed. I'm sorry, I said y squared the first time. It should have been y cubed. I had to distribute 2y squared across y minus 3 to get 2y cubed minus 6y squared. But then we have to subtract. That's this piece right here. We subtract that value, and so then so what you're going to do is you're going to end up taking the opposite. So this is 2y cubed minus 2y cubed and negative y squared plus 6y squared, or minus a negative 6y squared. So that's where the 5y squared comes from. Bring down the 0y. If you want to, you can bring down the 25. I often will do that, but you don't have to. And then you repeat the process. So y times what value is 5y squared. That's 5y. Distribute that across y minus 3. You get 5y squared minus 15y. Subtract this entire thing. So the positive here becomes minus, which will cancel out, become 0. Then negative 15y becomes plus, and when you add it to 0y, you get 15y. Repeat again, because I still have that y in here. So repeat again, y times what is 15y? Well, that's 15. Distribute, you get this function. You take the opposite, so 15y minus 15y is 0, and then 25 minus negative 45, so that's 45 plus 25 is going to give you 70. And so then this is going to be your final answer. So it was the quotient, the remainder, and the divisor. And one of the best practices that you can use to check your final answer is if you go ahead and use a graphing program, graph the original, and then graph the final. And those graphs should overlap. So moving into the next problem, we're going to use long division in order to divide, and but this time we have a non-linear divisor, but that doesn't really matter. Now there's something going on here. I can't quite see why it did this, but if you notice, there is a missing x term here, and so you want to write in your 0x, makes things a little bit easier to divide, which they've written here. And then you take your original polynomial, write it in descending order. Again, this is by powers, so x to the fourth, x cubed, x squared, x to the first, and then the constant. So that's a slightly different arrangement than what we had in the original problem. And then we repeat the same thing that we were dealing with in the prior problems. So 3x squared times what is 3x to the fourth? Well, that's just x squared. Distribute x squared across this value. Sorry, this one right here. You get this result. Take its opposite or subtract it from its prior. You're going to get this result. 3x squared times what is 9x cubed? That's 3x. Distribute, you get this result. Subtract the entire fraction, the entire expression, and bring down your last term. And so then we have this expression, 3x squared times what's negative 3x squared. That's a negative 1. Distribute across this function, you get negative 3 minus 0x plus 2, then subtract, and then what we end up with is 0, 0, 0. And so then that's going to be our final answer, which is x squared plus 3x minus 1. Again, if you took the original, and then you compared it to your final answer, those graphs should overlap. If, let's say for instance that this 0 was like a 4, then we would call whatever was left over the remainder and put it over the 3x squared minus 2. But in this case, it factored out nicely. Right. Next example, follow the same process. Write these in order. They're in order. They're missing a term, so go ahead and put that term in, and then start your division process. And in doing so, you're going to get a final answer with no remainder, which means that this is a factor. Synthetic division. It's a shorthand method of the polynomial long division. We use only the coefficient, and a couple of key things. In order for it to work, the polynomial has to be written in standard form, which means, first of all, descending exponents, and then put in a 0 for any of the missing terms. And then when we're talking about the divisor, this is what I mean by it's a linear divisor. I mentioned that just a little bit earlier in the video. It has to be in the form of x minus a, which, what if it was x plus 1? Well, x plus 1 can be rewritten as x minus -1. So it still counts. The main thing that we're looking for is x cannot have a leading coefficient. So you're not looking for like 3x minus a. If you do, you have to do something in order to kind of fix that. You have to combine, use a couple of tricks. And also, it's just x value, not something like x squared or x cubed or anything like that. So for synthetic division, so here's my original problem. I want to divide the 2x squared plus 7x plus 9, and I want to divide it by x plus 2. All of my criteria is met. I have all of the terms. I don't have any missing terms. I have a linear binomial is what I'm dividing by, and so then we go through the steps. I'm not going to go through the steps completely, but I'm not going to go through it word for word, but take what you're dividing by, so in this case that x plus 2, and then set that equal to 0 and solve for x. And then from that you're going to get this negative, you're going to get a -2. That -2 goes here. Okay, and then you draw just kind of a half box, and then to the right of that half box, the numbers 2, 7, and 9 come from the coefficients in your polynomial. The 2x squared, 7x, and 9. Your first step then is that you just you just drop this 2, just bring it straight down, and you don't do anything to that. The next step that you do is you take this 2 and you're going to multiply it by this -2, and that's what's going to go in the spot underneath the 7. So 2 times 2 is -4. Then you combine 7 plus -4 or 7 minus 4, you're going to get 3. And then repeat. Multiply again. So this 3 times -2, that's going to be -6, which is going to go into the next column underneath the 9. And 9 plus -6 or 9 minus 6, that's going to be 3. Now this very last column, you see the other half of the box, this is your remainder. And so what you're left with, these numbers here represent 1 degree less than the original. So we started off with x squared, so we're going to go 1 degree less, which is a linear factor. And so this is 2x, since that 3 is positive, plus 3, and then plus, it's best always to use plus, and then the remainder 3, which is right here, divided by the original divisor, which was x plus 2. So divide using synthetic division is the binomial a factor of the polynomial. If for this condition, is it a factor of the polynomial? What you want is a remainder of 1. You're going to want a remainder of 1. So take x minus 6, set that equal to 0, solve for x, and what you're going to get is that that 6 is the number that you're looking for. So a is going to be 6. Then write out your coefficients. So this is, if there's no number in front, it's understood to be a 1, -3, and then -18. And then when you synthetically divide, bring down the 1, multiply it by 6, move it to the next column. -3 plus 6 is +3, multiply it by 6. So that's 18, you move it to the next column. Combine -18 plus 18 is 0. So since there is no remainder, the quotient, remember we started off with x squared, so this number is going to represent 1x plus 3. That's the quotient, no remainder. Therefore, this was a factor. So this x minus 6 is a factor. Okay. This one, same style, except notice we're missing that x squared term. So make sure that when you account for a 0x squared whenever you're dividing, set this equal to 0, solve for x. That's finding this a value here, which is going to be a -2, because x plus 2 equals 0. Subtract 2 from both sides to get x to -2. So that's where this a is equal to -2 comes from. Set up your polynomial. Since a is a -2, that goes on this side of the box. And then you have your coefficients, 3, -1, since there's an understood 1 here. Since the x squared term is missing, that's 0, and then the +5 and the -1. Follow the synthetic division, drop the 3 times -2, -6, -1, -7, and so on until you get to your final value, which is 45. That is not 0, which means that is a non-zero answer, so x plus 2 is not a factor of the original. And then when it comes to writing it down, our leading term was originally x to the 5th, so this becomes 3x to the 4th minus 7x cubed plus 14x minus 23 plus 45 divided by x plus 2, the original divisor. All right. Now, what about in this case, where we have a value in front of the linear binomial here? The original setup for the process is still the same. So I like to say, set this entire thing equal to 0, and then solve for x, and what you would get is a positive 1/3. And so that's your a value. That's going to go into this problem. Write out the coefficients. This is 3x cubed minus 4x squared minus 17x, and then plus 6. So that's there's no missing terms here. So that's the 3, -4, -17, -6, and then notice the 1/3 here. The process here is the same, and the process here is the same. Bring down the 3, multiply by 1/3, and then combine. When this number is positive, you call it adding. When this number is negative, you can call it subtracting. I just use combining because it's universal amongst addition and subtraction. And when you go through the synthetic process, you find that there is a 0 remainder. So that means our binomial is indeed a factor. So 3x minus 1 is a factor. And then what we're left with as far as the quotient is 3x squared minus 3x minus 18. One thing that I want to say to this is if you are trying to simplify, and compare this answer to the original problem, you're going to see a mismatch in the graph, because if you notice 3, -3, and -18, they all have a factor of 3, and that is actually no coincidence. So you have to scale it, and so what I typically instruct people to do is that when you divide by a fraction like this, 1/3, whatever that number is under the bottom, you divide your entire polynomial by that same number, but you leave the remainder alone. So to compare the original problem, which is this, divided by this number, to get the exact same graph, your final answer would actually be x squared minus x minus 6, because I divided all of those numbers by 3. That came from right here. Finding a missing term. So now we have an unknown constant in this case, and then I want to know, well, what is it going to be such that my what does k have to be such that my remainder is 63 when I'm dividing by the linear binomial x plus 3. Set x plus 3 equal to 0, you get that your a value is a negative 3. Go ahead and plug in your coefficients. 6 minus 5 and k. Apply your synthetic division. Drop 6 times negative 3 is negative 18. Minus 5 is negative 23. Times negative 3 is positive 69. And then we want this result to be 63. So what does k have to be so that when I add 69 I get 63? K has to be a negative 6. Feel free to attempt these on your own. And if you have any questions, feel free to ask your instructor. Synthetic substitution says that if you take a polynomial and you divide it by a linear binomial x minus a, whatever your remainder is equivalent to if you were to take that polynomial function and evaluate it for a. So in this case, the polynomial x cubed minus 4x squared plus 5x plus 1, if I were to divide it by x minus 3, so solving for your a value, you get an a value of 3. If you go through your synthetic division process, you end up with a remainder of 7. And so this original function here, if you evaluated it for the value 3, which is represented here, your final answer is going to be 7. So you can actually evaluate a polynomial function using division. So I want to evaluate p for 2 given this polynomial 2x cubed plus 5x minus x plus 7. I can plug it in kind of the standard way and I get to a value of 41. But I can also call my a value 2 and I can use synthetic division and I'm going to reach the exact same answer. So it doesn't matter which method that I use. A highly probable type of question that you may see on something like the EOC would be this chart is partially filled out, and then you're asked what is this value going to be? What is this value going to be? And as well as this value to end up coming up with the final answer, because they're going to try and orchestrate a problem where you can't just do simple evaluation to get to the answer. So here's 2 problems again that you can try on your own. Okay. And so now after this we're going to look into more specific features when it comes to polynomial functions. I hope that this video made sense. Again, if you're struggling, please ask your instructors about what's going on. And we look forward to seeing you in the next video.